Alright, calculus. This is number 6 on the week 3 FRQ homework. Hopefully this question clicked pretty well because you just covered this on Thursday the 18th and Friday the 19th, so if you were saving it for the end, good one to save. Part A, where does f have a relative maximum? We're given f prime, so remember with your non-writing hand we're saying when does the original function change from increasing to decreasing, or positive to negative? It's only right there at x equals 3. So our justification would be at x equals 3, since f prime changes from positive to negative. And let's write it all out. Let's not use plus signs or minus signs. Positive to negative. F changes from increasing to decreasing. And a relative maximum exists. You wouldn't actually need both of those chunks. You could choose one, but I want to include both just so we're aware. Part B, similar question. Where is there a relative min? So my answer is going to be almost the exact same. Again, this is f prime. So I'm thinking, when does my original function change from decreasing to increasing? Or where does my derivative change from negative to positive? And it's right here at -3. We know these are zeros because it tells us 2 zeros right there, -3 and 3. So if you were unsure about the exact answer and you tried to graph it, first of all, we don't have a function, but second of all, they told you. So relative min, x equals -3, since f prime changes from negative to positive, a relative min exists. I'm not going to add that second chunk, but you could say, therefore f changes from decreasing to increasing. Part C, where is f concave down? Use f prime to justify your answer. So there's two ways you can say this. You could say either f double prime is negative. Remember, concave down, you could say f double prime is less than 0, or f prime is decreasing. We definitely want to use f prime because it tells us, but also I don't have f double prime graph. I only want to reference something that exists on the page here. So if we look at our graph, it's f prime. I better use f prime in my justification. Where is f prime decreasing? Let's go back to our graph here. It's this chunk from -2 to 0, and then from 2, some might say to infinity, but the graph stops at 4. So from -2 to 0, and from 2 to 4, since f prime is decreasing. I might want to add a little bit more. Since f prime is decreasing, therefore f double prime is negative, and f is concave down. Maybe just a little bit of clarity there, for my own sake. If f of 0 equals 0, find the value of the integral from -a to a. This is asking about symmetry. So it's saying like f of x from some negative value to the opposite positive value. Let's look at our graph. Do we see some symmetry here? I sure do. This question is kind of goofy because it's actually asking about the integral of f, not the integral of f prime, what we see here on the screen. So like we can't actually use this function. We can't use spam. It's giving us a value though. And that value, essentially I'm not like shifted up or down or anything. This is kind of a weird, question. But if the shown derivative has this symmetry, Remember how we talked about the power rule where like if I take a derivative of a even function, x squared, it becomes 2x, it becomes odd. And if I take a derivative of an odd function, x cubed, I get 3x squared, which is even. This question is kind of taking advantage of that fact. It says integrate f while we know that f prime is an even function. So what we're saying is like I see f prime. If I integrate from -2 to 2, it's going to add up a ton of positive space here. Any symmetric integral of f prime will add up a ton of space. But f looked something like this, and I don't know exactly, but it was somehow odd symmetric. So like let's say this was x to the 5th or something. This is something like 5x to the 4th. So this question is getting at the idea like when I take a derivative, degree decreases by 1. When I take the derivative of an odd function, it becomes this nice symmetric even function. And so since f of 0 is 0, we're saying my function does go through the origin, so it's nicely oddly symmetric, which means whatever I add up on the right side is going to cancel out what I've added up on the left. Now my graph doesn't show this, but that's the goal of this question, so maybe I could draw it a little bit more nicely. Well, that's terrible. It's good for this chunk, it's a little bit better. But the question's actually asking, like, since I see the derivative is even, the original function was odd, it has odd symmetry. So therefore, this is always 0. This is definitely the challenge section of this problem. I think A, B, and C are definitely reasonable for all of us to get. D, I don't even know if I would get this during the AP test. This is such a weird argument to make, and it's a pretty tricky thing to think about. So try and see if you can work it out. The justification would be something like what I just rambled about for a couple minutes. Tricky question for sure. Good luck. Let me know if you have questions.